All right, so you ready to dive into something pretty wild?
Laid on me.
Okay, so climate change, right? We know it's doing a number on things down here, but it's also messing with outer space.
Hmm, that's interesting. I'm all ears.
Yeah, we're talking like a greater risk of collisions way up there in orbit.
Really?
Yeah, I know. It's like, who would have thought? So we're looking at this article from Daily. It's called "CO2 May Increase Space Collisions," and it's kind of bringing to light something most people haven't even like considered.
Well, and it's, makes you think about how everything is interconnected. Like
Mhm.
what we do down here has consequences that like reach way beyond our planet.
Exactly, yeah. So the article, it dives into this atmospheric layer called the thermosphere, and it's where, like most of our satellites are hanging out hundreds of kilometers above Earth.
Okay, so what about it?
Well, here's where it gets really interesting. Greenhouse gases, the ones that are warming up the lower atmosphere, they're actually cooling down the thermosphere.
Oh, wow.
Yeah. Isn't that wild?
Yeah, that seems kind of counterintuitive.
Right.
So the same gases that are trapping heat near the Earth's surface are actually radiating it away
Yeah.
in the upper atmosphere.
Exactly. Like it's almost like imagine puncturing a hot air balloon, right? The heat escapes and then the balloon shrinks.
Ah, I see.
So a cooler thermosphere means it's shrinking. And that means,
Less density.
you got it. And less density means,
Less drag on all the like satellites and space junk flying around up there.
bingo. So, less drag. That sounds like a good thing at first.
Yeah, less friction, things move more efficiently.
Exactly. But
But it's not that simple, is it?
not quite. So think of it this way. Imagine a freeway with no speed limit, and there's just broken down cars, like littering the lanes.
Oh no. And in space, those broken down cars are moving thousands of kilometers an hour.
Yeah, exactly. So you've got more stuff hanging around longer, all crammed into the same orbital space. And,
Yeah, that can't be good.
no, it's definitely not. And it becomes a big concern when you think about something called orbital carrying capacity.
Orbital carrying capacity.
Yeah. And this MIT study that we're looking at suggests some popular orbital regions could see their carrying capacity shrink by like 50 to 66% by the end of the century.
Wow. Compared to, what, the year 2000?
Yeah.
That is a massive reduction.
I know. So are they basically saying we're running out of room in space?
Well, in a sense, yeah. There's only so much space up there where we can safely operate satellites. And with less atmospheric drag to help clear things out, it's getting crowded.
Wow. So are there other factors at play too?
There's one more thing.
Okay.
It's solar minimums.
Oh yeah, solar minimum. Those are periods of low solar activity, right?
Right.
So how does that all tie into this? Like, does the sun also impact the orbital carrying capacity?
Absolutely. It really does.
Mm.
So during solar minimums, the sun emits less ultraviolet radiation. And that actually causes the thermosphere to like contract even further. So less energy from the sun, lower density, even less drag.
So it's like uplink
It's almost like turning down the volume on the atmosphere's ability to Right. kind of clean itself up.
Wow. Okay, so we've got greenhouse gases making the thermosphere shrink, and then we've got solar minimums making it even worse. And all of this is leading to what exactly?
Well, it brings us to one of the most concerning possibilities, Kessler syndrome.
Okay, Kessler syndrome. I've heard of that, but it sounds pretty ominous. Can you break that down for me?
Sure. So imagine a chain reaction of collisions in space. One collision creates thousands of pieces of debris,
Uh,
and each of those pieces can then trigger even more collisions and so on and so on.
oh, wow.
Yeah, and it's like a runaway cascade of destruction that could essentially turn low Earth orbit into a no-go zone.
So it's almost like a domino effect, but in space and with huge consequences.
Exactly. And the reduced atmospheric drag we've been talking about, due to that shrinking thermosphere, makes that cascading effect even more likely.
Wow. Okay, so this is some pretty unsettling stuff. But before we spiral into like a black hole of despair here, is there anything that can be done to prevent this? Like, are we just sitting ducks here?
Not necessarily,
Mm.
but I think we need to get into that in part two. It's a complex issue with no easy answers, but there are definitely things we can do to mitigate the risks. Yeah, it's definitely a wake-up call,
Yeah.
but I don't think it's like a reason to panic.
Okay.
There are things we can do
Okay.
both technologically and in terms of like international cooperation to kind of tackle this challenge.
Okay, so let's dive into those solutions. What kind of technological innovations are we talking about here?
Well, one area of focus is on developing better ways to deorbit satellites at the end of their, operational life. So imagine equipping these satellites with like a drag sail that increases their surface area and helps them fall back into the Earth's atmosphere more quickly.
So we're basically helping them self-destruct in a controlled way,
Yeah,
burning up harmlessly in the atmosphere.
exactly. And then there's the even more ambitious idea of active debris removal.
Okay.
So we're talking specialized spacecraft equipped with robotic arms, nets, or even harpoons to capture larger pieces of debris.
Space harpoons. That sounds like something straight out of a sci-fi movie, but it's also really cool.
It is exciting stuff.
Yeah.
But, technology alone isn't enough.
Right.
We also need a strong framework of like international agreements and regulations to govern space activities and ensure everyone's kind of playing by the same rules.
Right, because space is a shared resource. It's
Yeah.
not just a free-for-all.
Exactly.
So what kind of rules are we talking about here?
Well, think of it as like establishing the rules of the road for our space highway. So we need clear guidelines on things like satellite disposal, debris mitigation, and even like traffic management in those increasingly congested orbital regions.
So almost like having air traffic control, but for space.
Exactly.
That makes a lot of sense. But getting all the nations of the world to agree on something as complex as space governance, that can't be easy.
It's definitely a challenge. But the good news is that there's like growing awareness of the problem
Okay.
and a growing recognition that international cooperation is like essential.
Right.
We're seeing increased collaboration between space agencies, industry stakeholders, and policymakers.
Okay.
There's like a real sense of urgency starting to emerge.
Okay, so we're not just talking about cleaning up the mess we've already made.
Right.
We're also talking about changing the way we think about space and how we operate there.
Exactly, yeah. We need to shift from a mindset of launch and forget to a more sustainable approach.
Okay.
Imagine a future where every satellite is designed with end-of-life disposal in mind, where debris removal is a standard practice, and where we have a global system for tracking and managing space traffic.
It sounds like a pretty ambitious vision, but it also feels like a necessary one, considering everything we've learned today about the unintended consequences of our actions.
Yeah.
Like CO2 emissions impacting the density of the thermosphere.
Right.
Who knew?
Yeah, it's a reminder that we're all interconnected, down here on Earth and all the way up in space.
Well said. All right, so we've explored the problem. We've talked about some...
Absolutely. From communication networks to GPS navigation to Earth observation, we depend on satellites for so much.
Yeah.
Protecting the space environment is ultimately about protecting ourselves and ensuring a thriving future for humanity, both on and off our planet.
It's really mind-blowing, to think that something we're doing down here to like combat climate change could actually be causing problems up in space. You'd think like reducing emissions would be a universally good thing.
Right.
But it's not that simple, is it?
It really highlights how important it is to take like a holistic view. We can't just focus on like solving problems in isolation.
Yeah.
We have to think about the interconnectedness of everything.
Right.
And the potential for, unintended consequences.
For sure. So where do we go from here? We've talked about some promising solutions like deorbiting systems and space debris removal. What else is being done to address this challenge?
Well, there's a lot of, exciting research and development happening in the field of space situational awareness.
Okay.
So it's all about improving our ability to like track and monitor objects in orbit, from active satellites down to the tiniest pieces of debris.
So it's like creating a much more detailed map of everything that's up there.
Exactly. And with better tracking, we can predict potential collisions.
Yeah.
Like more accurately.
Yeah.
And even maneuver satellite out of harm's way.
Got it.
It's like having a sophisticated air traffic control system for space.
That sounds crucial, especially as the orbital environment just gets more and more crowded. But all of this, from the technological solutions to like the international cooperation, it's going to require a lot of resources and commitment.
There's no doubt about it. But I think the investment is worth it. The space economy is growing rapidly.
Yeah.
And our reliance on space technology is only going to increase in the coming decades. So protecting this like valuable resource is essential for our future.
Yeah. What strikes me is that this whole issue of CO2 emissions and space collisions, it feels like a microcosm of the larger challenges we face, in the 21st century.
Yeah, I think you're right. It forces us to confront like complex scientific concepts and grapple with the ethical implications of our actions
Yeah.
and find ways to collaborate on a global scale.
Yeah.
It's a reminder that the choices we make today will have far-reaching consequences, not just for us, but for future generations.
Well said. So, as we wrap up this deep dive, what's the one key message you want to leave with our listener?
I want them to understand that we're not just passive observers in this cosmic drama.
Yeah.
We all have a role to play in shaping a sustainable future for space exploration.
Right.
Whether it's supporting research and development, advocating for responsible space policies, or simply staying informed about the issues, our actions matter.
It's a call to action for all of us, isn't it?
It absolutely is. The future of space is in our hands.
Well said. And with that, we'd like to thank you for joining us on this deep dive into the surprising connection between CO2 emissions and the risk of collisions in space. We hope you've come away with a new appreciation for the complexity of our planet and the challenges and opportunities that lie ahead. Until next time, keep exploring, keep learning, and keep looking up.